Question number 51. Consider the following reactions. So we have cyclic compound. It is first allowed to react with zinc in presence of alcohol. So zinc alcohol is going to cause dehalogenation in this case, and the product P1 obtained shall be this. Now it is allowed to react with aqueous KNO2 in presence of HCl. It will cause diazotization, and we are going to have the formation of N2 plus, which will then leave, leading to the formation of this intermediate. So this is the P2 intermediate which is mentioned to us by the examiner in the question, and this will further react with the water molecule present in the system to give us the alcohol. Okay, so this is the final product, which is P3. Now let us look at the options. In statement 1, the examiner says that P1 is cycloalkane. It is incorrect, students. P1 is not cycloalkane, it is cycloalkene. If you look at S2 now, P1 is a chiral molecule. This is also incorrect, students. The product P1 is going to have a plane of symmetry which is passing through the NH2 like this. So this will be optically inactive. So the second statement is also incorrect. If we talk about the third statement now, P1 is aromatic. This is also incorrect, students. P1 is not aromatic. If you look at the fourth statement now, it says that P2 is aromatic. This is correct, students. The compound P2 is aromatic in this case. If you look at S5 now, P3 has 3-membered ring. This is also correct, students. P3 has a 3-membered ring. And if you look at the sixth statement, P3 has 2 3-membered rings. This is incorrect. P3 has only 1 3-membered ring. So if you look at the statements which are correct, we have only S4 and S5 as correct. But the examiner is interested in the statements which are false. So we can see that we have to mark the third option as the correct answer to this question, in which S1, S2, S3 and S6 are not correct. So the correct answer to question number 51 is option 3. Let us look at question number 52 now. Consider the following reaction. So we have 2A converting into 3B. The given rate constant for this reaction is 2.303 into 10 to the power minus 3 minute inverse. So it is going to be a first order reaction by looking at the units of the rate constant. So the examiner seems to be interested in the time in which the molar ratio of A to B is 4/3. So we can first have the rate law expression. So we have dA by 2 dt shall be equal to minus of K times the concentration of A. So this on simplification will give us AT equal to A naught e to the power minus 2 kT, or we can say that ln of A naught by AT, it shall be equal to 2 kT. Now we have been given some further information which says that the molar ratio of A to B is 4/3. So we can solve for that concentration. So we had A naught minus 2x shall give us 3x. So it is given to us that A naught minus 2x by 3x is equal to 4/3. It implies that A naught is equal to 6x. So now if we put the value of x in terms of A naught in the expression which we had derived before, we can see that we're going to have ln of A naught upon A naught minus 2x shall be equal to 2 times into k into t. So if we simplify this, we're going to have ln of 3/2 is equal to 2 times the value of k is given to us 2.303 into 10 to the power minus 3 into the time t. So ln 3/2 can be written as 2.303 log of 1.5, and this shall be equal to 2 into 2.303 into 10 to the power minus 3 into t. So on solving this expression, we're going to have the value of t equal to log of 1.5 into 1000 upon 2. So this will give us a value of t equal to 85 minutes. So students, for this question we have to select the second option as the correct answer. Let us look at the next question now. Question number 53. Using inert electrodes, acidified water is being electrolyzed. The total volume of gases collected at cathode and anode is 4 VmL at 273 Kelvin and 2 atmosphere. The amount of charge passed during the electrolysis in the electrolytic cell is equal to, in terms of V and the Faraday's constant F. So if we talk about the conditions which are given to us, we have 273 Kelvin, we have 2 atmosphere, and at this temperature and pressure conditions, we have the volume as 4V. If we try and convert it into STP, so STP will have 273 Kelvin and the pressure will be 1 atmosphere. So the equivalent volume when converted to STP shall be equal to 8V. So we can now deal in terms of STP, where the volume of gases liberated shall be equal to 8V. Now, if we talk about the total volume of gases which is being liberated, so we have electrolysis of water going on. It will give us H2 plus half O2. So we're going to have the formation of H2 and O2 in the ratio of 2:1. So if we talk about the total volume of H2 which is liberated, it is going to be 2/3 into the total volume, which is 8V. So the volume of H2 evolved shall be equal to 16/3 into V. Now if we talk about the moles of H2, we have to divide this volume by the molar volume, which is 16V/3 into 22400 ml. Now if we talk about the number of electrons, so 2H plus 2 electrons give us H2. So per mole of H2 liberated, there will be a requirement of 2 moles of electrons. So the total moles of electron passed shall be equal to 2 times this number. So 2 into 16V upon 3 into 22400. And if we talk about the total charge passed, Q, it shall be equal to the number of moles into the Faraday's constant. So we have 2 into 16 into V into F upon 3 into 22400. So if we try and simplify the value which is given to us, we're going to have the value of Q equal to Vf upon 2100, which is given correctly in the first option. So students, for this question, we have to mark the first option as the correct answer. Let us look at the next question now. Question 54. Consider the following method of formation of colloid. So AgNO3 is mixed with excess of Ki. Which of the following is correct? So the examiner seems to be interested on the charge on the colloid, and the examiner is also interested on the ion which will get absorbed. So if we talk about AgNO3, which is mixed with Ki in excess, so we're going to have the formation of AgI first, and then on this AgI there will be the adsorption of I minus as it is present in excess. So the colloid particle will be negatively charged due to the adsorption of I minus ions. So students, for this question, we have to select the second option as the correct answer, which says that the colloid will be negatively charged due to the adsorption of I minus ions. Let us look at the next question. Question number 55. In the following processes, certain PV work is done along different paths. So students, in this process, we have a system going from state A to state B along 3 different paths, 1, 2 and 3 as mentioned in the diagram. So the examiner seems to be interested in the value of the change in internal energy along these paths. Students, we know that internal energy is a state function. So if it is a state function, it will not depend upon the path taken. The value of internal energy change along all these paths shall be equal. So delta E1 shall be equal to delta E2 shall be equal to delta E3. So students, for this question, we have to mark the third option as the correct answer. Let us look at the next question now.